So imagine a time you are sitting in a physics class, okay, your hands on the table like this. You are daydreaming something, not listening to what your teacher is saying, and then lost in your dreams. Will you call it as a motion? No, obviously. But suddenly your teacher asks you something to take out the homeworks that was given in the last class. And you will be active with a speed, opening the bag, taking out the copies, flipping the pages and finding that did I did the homework or not, or acting like yes, I am searching for the homework. Is happen? Yes, this is something that happens to every student watching me right now, which we will call as motion. And this is what the chapter is about, describing motion around us. Hello, my dear students. Welcome on the platform. Deeksha, Vedantu, and I am your faculty, Tanvi Ma'am. Today, we are going to learn this important topic from your class 9th book, important chapter from your class 9 book, that is describing motion around us. Every time I teach anything, I ask you to decode the heading. Decode the heading of the chapter, and here it is, describing motion around us. Beta, since we are child, right? Since we started learning something in science, one example has been always given to us, that consider you are sitting in a train. Consider that you are sitting in the train. When you will see out of the window, you will feel that those trees are moving, but actually those trees are not moving. It's you who is moving. Obviously, this is the same example we are being told every time, but today's class we are not going to learn from those boring examples. We will learn it in the most interactive way possible. Right? Actually, those trees are not in motion, they are at rest. It's you who is in the motion in a train sitting. But a person who is sitting beside you, in the train will find you not in motion but at rest, because the person feels that you are not moving. You are sitting at the same place. So this is how the dynamics of physics we have to learn in this today's session. Welcome again on the same platform. Before moving to the session, let me tell you one basic thing that we are going to learn is types of motion, right? There are basically beta the types of motion, right? Types of motion, number 1. What is that? That is basically linear motion. Okay, that is basically what beta? Linear motion. Now, let's see the example of linear motion. You are a student A, right? You are a student A. You took the permission from your class teacher to go to washroom. You went to washroom straight and came back in a straight direction. This type of motion is known as what beta? Linear motion. Right? The second one, which is known as circular motion, which is known as what, my dear students? Circular motion. Now, what is this? Right? You are a student A. You want to go to a location at B. Location is your washroom. But you were feeling that your class was very, very, very boring. And now you decided to take a complete circle of the playground and then reach to the location B. Right? When you were coming back, you find that the last route was boring. Let me take another circle and go back to the point A. This is known as circular motion. This is known as what? Circular motion. Is there anyone who do that? Please tell me in the comment section. And the third one, that is oscillatory motion. Okay, the third one, that is known as bacha, the oscillatory motion. Oscillatory motion we usually see in the clock. Right? We usually see in the clock when the pendulum is moving like this. The pendulum is moving like this. It is oscillating. I will tell you the best example for that. Right? Now, you have your friend's birthday tomorrow. You went to your mother that I need to go to the party. Right? What your mother will say? Ask to your father. You went to your father will say, please ask to your mother. Now this cycle is going on and on and on and on and on and on, and this type of motion is known as what? Oscillatory motion. These are the 3 types of motion we have to study. Other than motion beta, see, right now I am standing here doing nothing. Neither I am walking, neither I am crawling, neither I am doing anything. what will my body be known as? The body is at rest. But now then I started walking, dancing, talking to you, moving here and there, and this is what is known as motion. So we have two instances when the body is at rest, or the second instance where the body is moving. Right? Your car is being parked in a parking lot and you are sitting there eating burger because your parents are meanwhile doing the shopping. You are at rest, but they are at motion. These are certain basic examples which we have to understand before moving straight to the chapter. And now the chapter begins, which you will start with thinking some questions, because after the end of the session, I want that these questions are crystal clear in your mind. And the question one is, how much distance should we maintain from the truck ahead to avoid a collision if it is suddenly applies the brake? See, being in India, one of the craziest thing I read every day are those slangs written behind the trucks, right? Is it? Read it and you will enjoy it. So, majority of times one more thing is also written, that keep distance. Why it is written? Okay, we actually know about the basic things, that whenever the truck will apply the brake suddenly, we have to maintain a distance. We have to maintain a distance so that they will not be collided with each other. But how much distance? According to what the speed the distance should be kept? Right? All these answers will be clear through this video. Question number 2. Does the safe distance depends upon the speed, as I told you right now, which means we are moving? Does it depends upon the speed? Does it depends upon the distance? Yes. Right? And that will be decoded through this session. Motion is everywhere. Obviously, motion is everywhere. You can look at the flitting butterflies. You can see how butterflies are flying. A bouncy motion is there. Again, a bouncy motion is there. Then there is difference in motion by which horses are galloping. Right? There is difference in motion in the movement of the snake. Right? It is not bouncing. It is just rolling. Then we can say rising and falling of the ocean tides. Yes, that is also a motion. Gathering clouds from massive astronomical objects to the subatomic particles. Whenever you see that sunbeams are coming, you will see small particles moving out there. That is also an example of the motion. So around you, everything is motion, and physics tells us science behind it. That is what we have to learn. To explore these concepts, phenomena in detail, class 9 students, this chapter is added in your syllabus. We will learn this with the help of what we can say formula, with the help of graphs, and with the help of lot more concepts which we have to clear in mind. Okay, so what you are going to study in this chapter? Motion in a straight line, that linear motion we gave you the example, like you went to washroom from your school classroom and went back, came straight back. This is motion in a straight line. Then you will learn about its graphical representation, kinematic equation to solve all those numericals which you are eventually scared of, and motion in a plane. Okay, let us begin with the very first topic of the day, that is motion in a straight line. By very easy. Motion in a straight line is also known as linear motion, when you are moving in a way that, right, their movement is in linear way. That means in a straight line. Now, your person who is learning swimming or took part in any of the swimming contest, what is being said, that by this is the way through which you have to go. So this is the position A. You have to reach to the position B in a straight line. Okay, in a straight line you are moving, and hence it is known as motion in a straight line. Simple, very simple. Right? You have seen lot of car racing. You are playing games of car racing. What is happening, beta? There is a pathway provided for the movement of the car. This is motion in a straight line. You can see train running on railway tracks. This is motion, or the object is moving in straight line. Right? When children crossing the swimming race, a vertical falling ball, again a vertical falling ball, a car on a straight stretch of highway, a train moving on a straight track, all these motions are considered to be as motions in straight line. But this is not something which we will study as we are moving towards class 9th. There are a lot more concepts to be cleared here, and the first is First is beta, to learn more about motion, we need to understand certain points like position. Its position, right? Its magnitude, its speed, its acceleration, and a lot more thing. We will start with the first point, that is describing position, right? Now, I have sent you to buy some, like I usually do it with my younger siblings, right? I give them just 10 rupees and ask them to buy lace, right? But what happened? Will they go straight to the shop and bring it? No. Meanwhile, there are a lot of times they are spending time with their friends, stopping at each and every point, sometimes started playing cricket, etc., etc. Right? I will call them and ask them, where are you? They will say, oh, I am on my way, just 2 minutes. Getting my point? But, right? 2 minutes from when? 2 minutes up till when you are going to come? So here the very first important point is to learn about position. Okay? There are a lot of examples. For examples, let's see this running track. Let's see this running track. So here is a person A, right? Pay attention to that. Here is a person A and a person B. There are two people, right? There are two people. What happened? Person A started running and reached towards point B, which is around 100 meters away, but suddenly this person B, got a twist in his leg and stood there itself. Now what you will call that? Beta, this person was at rest, right? This person was at rest. However, this person reached in its stage of motion. Now what happened? When I talk about the position of both the people, what I will say here is, beta, in motion, the position with respect to the reference point, that the person started moving point A and has reached to the point B. So when I'm talking about, this is the position of this person B with reference to what? From where he started. This is very, very important. Right? However, at rest, the position of the person with respect to the reference point will not end here. But everything has a reference point. Like in maths, you study what? You study number line. So, from where do we study the number line? From 0. Like in history, we have the reference point, that the birth of Jesus Christ. Now, the period before that is BC, the period after that is CE. So, always to learn about the motion, we should have a position to the reference point from where we are talking about this person. From which reference we are talking about the motion. For example, right? For example, today, me and my mama went on a walk and then come back at home. I was telling my father that we had a walk for around 2 kilometers. So, I'm talking from which reference point? I am talking from where we started the walk. But right now, again, we are at the house. It does not mean that we did not had the walk. We have it. We were in motion, but from a reference point, that is my home. But from a reference point, my home. So basically, when I talk about it, beta, there are certain signs. Sign of the origin is considered to be as 0. The 0 is that reference point. For example, my home is at a place A. Right? I started walking and reached to the point B, that is my friend's house, reached to the point B. So my position with the respect of this position, with the respect of my house, will always be positive. But then what happened? I remembered that I have to also go to one of my friend's house, that is C, that is behind my house. Now, my position to this reference point will be negative. This reference point will be negative. But when I have to come back to my house after being in motion for a long time, I will reach to my reference point, that is 0. So yes, your position can be 0, it can be positive, or it can be negative with the reference point. With what, my dear students? With the reference point. Get it here? So this is about describing positions. Let's move beyond about two small things, right? It is very small for our knowledge, but there are a lot of students which get confused over it. There are two words, that is an instant of time and active interval of time. What is that? Like for example, if I ask you a question, right? What is the time right now? You will say that, ma'am, it's 10 a.m. in the morning. right? That is that instant of time. That is that instant of time. But I will ask you the reading of two particular slot, that by which time I gave you the homework. You will say, ma'am, 10 o'clock. And now what is it? It is 12 o'clock. Since 2 hours you are not able to complete your homework. What is that? I am here talking about, beta, interval of time. I am talking about interval of time. So here I am referring a time. Reference of a time is being used. Getting my point? So this is the basic difference between an instant of time and interval of time. Why? Why it is being told here and why it matters? Because we will study lot of concepts in this chapter, like average speed, average velocity, average acceleration, which we have to define from 2 points. Right? For 2 points, that by the person was here at point A, now the person is here at point B. Now tell us the average velocity. Now you might be thinking, what are these words? Velocity, acceleration, etc., etc. Hold on, everything will be clear, but it can only be clear when you know the difference between two basic things, instant of time as well as interval of time. Right? Now let us move towards this example, which will clearly tell us about the basic concept of distance. Distance and displacement. I am just hoping that you have heard these words, that is distance and displacement. So let us take the example of an athlete. Okay, athlete started moving from this position. We are considering it as a reference point, 0 point, okay, 0 point, and started running towards the point A, towards the point A, beta. So when he was moving from point 0 to point A, he covered how much distance? You can clearly see that it is 100 meter covered till point A. Okay, so what is the distance covered by an athlete? Distance covered by athlete here in the time, that is 10 seconds, beta, it is 100 meter. Clear? But now what happened, right? This motion in the straight line can be either unidirectional, that means in one direction, or it can be either in bidirectional. Yes, obviously. For an example, you started moving from your house to your school because you are having exam day today. But meanwhile, you remember you forget your school ID. You will come back with more speed, right, at your home, and will find that if your mother will not see you, take your ID back and then go back to the school. So yes, that motion in a straight line or linear motion can be either unidirectional or it can be bidirectional too. So what the example tells us, there is a person, there is an athlete that starts from 0 meter, move towards 100 meter, then return back and reach this point B. What is the total distance? Right? What is the total distance that is basically covered by this person A? So see, from 0 to 100, it is 100 meters plus 100 to 40 minus, how much it will be? 100 minus 40 by 60. So it will be 160 meter that is covered by this athlete. Right? OA plus AB, that will give us 160 meter. But now comes to the question. Right? Ma'am, will the displacement be same? As you have told here, beta, there is difference between distance and displacement. Yes, there is a great difference between distance and displacement. When distance is 160 meter, displacement is not going to be 160 meter. Why? Right? Why, beta? Because the displacement of an object in motion, right? The displacement of an object in motion is basically the shortest distance. Pay attention to it, this word, right? Shortest distance between a person moving from destination to the original position. For example, ma'am, please tell us what it is. It is the shortest distance. So, my dear students, let me tell you one big thing. Again, you are a student A. Right? You are a student A. Okay? Now you went to washroom asking your teacher because you were quite bored. You were quite bored in your class. So the distance between your classroom as well as your washroom is just 100 meter. Is just what, beta? 100 meter. Right? So this is a case A. This is case 1. When you went to the washroom straight, without not going here and there. In this case, your distance will be what? Your distance will be 100 meter for obvious reasons. Your distance will be 100 meter. Right? And when I talk about displacement, right? When I talk about displacement is basically the shortest distance between two points, right? The point A and point B. What is the shortest distance? 100 meter. In this case also, your displacement will be 100 meter. Now, but you were so bored in your classroom that you took another way to reach your class. So, 20 meters you moved in a corridor. Then you moved in a corridor which is around 100 meter, then reached to your washroom, that is again 20 meter here. Right? So in this case number 2, when I ask you that how much distance did you cover to reach to the washroom, because you were bored in your physics class, then you will tell me, ma'am, it is 20 plus 100 plus 20, 140 meters. 140 meters. But if I will ask you what is the displacement of the same, beta, displacement is the shortest distance covered by an individual to reach from point 1 to point 2. And again here, the displacement will be 100 meters. Displacement will be 100 meters. That means less than the distance. Less than the distance. Here you have to mark one thing, beta. You have to note one thing, that displacement will be always either equals to distance, okay, equals to distance, or the displacement will be less than the distance. Less than the distance. One question to everyone watching me right now, can displacement be more than distance? Think about it. Arey bhai, the definition of this word always contain a word that is shortest, and how can it be more? Right? So it can be either equals to distance, it can be either less than distance, but it cannot be more than distance. I hope that, right? I hope that this concept is quite clear to you. Distance as well as displacement. Right? Distance as well as displacement. But ma'am, here in both sense we are talking about what we can say, area covered by a person, right? A distance covered by a person. Can you brief more difference among them? Yes, my dear students, there are two parameters on which the definition of distance and displacement actually depends upon, and that is the magnitude as well as the direction. Magnitude as well as the direction, and both matters. Both matters, right? Magnitude basically means number. Magnitude basically means number. Now here number is distance between the two positions. Distance between the two positions, point A and point B. However, when we talk about the direction, it actually means from the first person towards the second. From the first person towards the second. Right? So here distance depends upon number, however the displacement depends upon the direction. It depends upon what, my dear students? Direction. When we talk about the SI unit of both the quantities, it will be same, that is meter. Right? That is meter. When I will ask you how much distance you covered while traveling to the washroom, it means only distance. It means only distance, that by I have covered 140 meters. It does not matter from where you went, how you went. No direction is required. But when I ask you about the displacement of a place, beta, the direction will be required, because when we have to figure out the shortest distance, we should know the direction too. That if we reach from this direction, then only the shortest distance can be covered. Hence, displacement becomes a vector quantity and distance becomes a scalar quantity. And now those two new terminologies we will understand. We will understand. First, we have to see this. Right? When I say that this is the sure question that is going to come in your exam, you have to right now write in your NCERT or somewhere in your copy. And what is that? By write the 5 differences between. right? Write 5 differences between bachcha what? Distance and displacement. Distance and displacement. Let us start. So what is distance by? Total path covered by a person from point A to point B. This is known as distance, right? However, displacement is, there is what? Basically, it is net change in position. Net change in position means, so this is a point A, person started moving towards B, sorry, this is point A, a person, this is a point O, a person starts moving towards A, came back and reached to the point B. So, if I am calculating the distance, I will say that the movement of a person is OA plus AB. But when I talk about displacement, I will say that the displacement of the person is OB, that is net change in position. Initially, the person was at point A, now the person is point B. This is the net change. This is what is known as net change. Now, in here, in distance, there is no numerical value only, right? So, basically, here there is only numerical value, only numerical value is there, no direction is there, right? No direction is there, right? However, in displacement, beta, we have both magnitude, that means number, like here, I will talk about the distance covered in 0 to B as well as the direction also. Okay? Can it be 0 while moving? Think about it. Can distance be 0 by? No. When you are in motion, you actually covered some part of the distance and it cannot be 0. But can displacement be 0? Yes, it can be displacement be 0. You started from point A, reached to point A, came back at your home. Again at point O. Oh, you covered the distance, but your displacement will be what? 0. Because what is the definition of displacement? Right? What is the definition of displacement? Think about it. It is the change in position from your initial point to the final stage. Okay? Next will be beta SI unit, that is again meter, same for everything. If we look at back to this figure, right, we will see the what is the distance in this figure? 160 meter. But what will be the displacement in this figure? It was just how much? 40 meters. And this is how the difference is created. Net change in the position of the object with reference to reference point at a given instant of time. This is known as displacement, and this is how it differs from distance. Let us analyze more with the examples given in your NCERT this time. NCERT is little tough, right, in terms of numericals, but it's not impossible. They have just leveled up something which is quite helpful for you in class 11th and 12th. Okay, so don't worry about this particular thing. Now coming towards the second example, beta, you are at point 0, right? You are at point 0 and covered 0 distance. You are having a ball in your hand and you just throw it upward. In the upward direction, we usually do this. Okay, see, this ball moved from 0 to A, covered 40 centimeter, then reached to B, 140 centimeter, came back to point C, covered C, 80 centimeter, reached to somewhere between 60 to 40 centimeter, and then came to its original position. For each position 0, A, B, C, O, record the total distance travelled by the ball from 0 till that position, the displacement of the ball from 0 till that position, and this is our work that we have to do. Right? Let's start this. Okay. So, for point number A, ठीक है, for point A, okay, what is the distance, beta? What is the distance that is covered from point A? So 0 to A, they covered how much centimeter? 40 centimeter, right? What is the distance, beta? The change in the location of the object, right? What is that? Again, it is 40 centimeter. Okay. Here we can claim that distance can be equal to displacement. Distance can be equal to displacement. Okay, bhai. Now moving towards next thing. Next is beta what? From the point B. So for the point B, what is the distance covered by the ball? Distance covered by the ball is around 140 centimeter. What is the displacement? Net change in the position of the ball. Again, the displacement is also 140 centimeter, which clearly states that, what does it state? That yes, distance can be equal to that of displacement. Moving further towards point C. Okay, point C. What is the distance covered by the ball? C. Pay attention. It started from point A, reached point B, 140 centimeter. Then point C. Now 80 and 140 is how much? Minus karo. 80, 90, 100, 60 centimeter. So 100 plus 60, how much it will be? So it has covered beta 160 centimeter. But when I talk about displacement, that is change in position of the ball from its initial to final position. How much it is? It is point C is there and the initial point is there. Okay? This is its final position, this is its initial position, and you can see the displacement is just 80 centimeter. Here we can say that displacement can be less than distance. Proved? Okay. Next is bas khatam. These are the only points which were given. Very good. So it can be 0. So then choose the true statement regarding to what beta? Regarding to displacement. Okay? Here we have to analyze regarding to displacement. Can displacement be 0? Yes, it can be 0 because when it started from position is O and came back at the position O, right? The distance covered by it is 140, 140, 280. But the displacement, the final position as well as initial position is same, and hence displacement can be 0. It can be 0. So choose whichever is true statement. This is not true. Its magnitude can be greater than the total distance. Magnitude matlab number. Can it be ever greater than the total distance? By not at all possible. Its magnitude is less than or equals to the distance traveled. This is pretty correct every time. See, here it is equal, here it is less, and when it reaches to the ground, it becomes 0. 3 chances are there. It can be less than it can be equals to that, it can be 0, but it can never be greater than it. And hence, the magnitude of the displacement can never be greater than distance. Think about it and prove it with the other examples too, which you see in your daily life. Okay, let's move to the next one. Right, check yourself. So there are a lot of questions given in your NCERT which we will solve today itself. And the questions are, in the example of an athlete running back and forth on a straight track, when will her displacement be 0? Why? When will the person's displacement be 0? So the running track was like that. O is the original position. Person reached to the point A, covered 100 meter. Tell me in which condition the displacement can be 0. So beta, the displacement can be 0 when the person started moving from this point O, reached to the point A, and then came back to the same point. It can be 0. Right? What will be the total distance traveled in this case? So the total distance will be twice, that is 200 meter. Very easy. Very easy. Next, chalo. Fuel used in vehicle depends upon which of the following. Justify your statement. This is quite easy. So beta, you have a car. Okay? My car looks like this. Don't make fun of it. Arey yaar, it is looking like a house. Very bad in drawing. So my car looks like this, right? I went to a petrol pump and filled it with the fuel. Right? Filled it with the fuel and then then I just went to the city, right? And for no reason I was just rolling out, right? And then came back home, right? Came back home. So according to that, my parents will ask me, because they were not at home meanwhile I was doing that, Arey, the fuel might not be used because the car is at home. You didn't went anywhere. Actually, I did. So the displacement is 0, the displacement is the 0, but the distance was not. and hence the fuel used in the car does not depends upon the displacement, it depends upon total distance traveled. Very easy. Next, a ball rolls down the inclined track. So there is a track like this, inclined track, and here is a ball rolling down it, right? Is this motion a straight line motion? First you have to answer this. So by yes, this motion is also a straight line motion. It is not circular, it is not oscillatory for obvious reasons. Fine. Taking O as the origin point. So see, this is the origin point, right? The total distance traveled and the magnitude of displacement equals at point A, B, C and D. So the ball started moving from point A, reached A, B, and then A, B, C, D. They are asking you that, beta, the distance traveled and the magnitude of displacement equal at A, B, C, D. Yes, because the track is straight and the ball never turns back. Why? They have told you the inclined track, because the ball can't come back by itself until a force is applied on it. So the position of the distance traveled will be equals to that of displacement. The displacement will change when the direction will change. The displacement will change, beta, when the direction will change, and hence it is vector quantity, right? We'll tell you about scalar and vector. This is the basic difference between distance and displacement, where distance depends upon magnitude, displacement depends upon its direction. Next, okay, you walk 60 meters from your home to the school gate. Okay, you are a person A, right? This is your house basically. Your person starts moving towards point B, that is your school, and how much it is? 60 meters. Realize you forget your ID card. If you are doing this now, don't do that, okay? Realize you forget your ID card. Walk the same 60 meters back you walked here. Find the total distance traveled by 60 plus 60, 120. The total distance traveled is 120. But find the displacement. You started from your house, you reached to your house, your final as was initial position is same. Okay, why? Because your direction changed. Once you were going from home to school, now direction changed from school to house, and hence it is 0. Hence it is the displacement becomes 0. Here concepts come of scalar as well as vector quantity. Now what is scalar, beta? The physical quantity which can be specified just by its numerical value, like distance, right? Like distance. Distance can only be explained in its numerical value. I walk for 10 meters, right? I drive for 1 kilometers. This is what? Distance, which can only come with a number, with its magnitude. However, when I talk about vector quantity, beta, this is also a physical quantity, right? This will also be given as a unit meter, but along with the magnitude here comes the direction too. Along with the what? Magnitude comes the direction too. As I told you, beta, you started from point A, reached to the point B, and then came back to the point A. You are changing your directions, and hence this is the concept known as displacement. This is a vector quantity, not a scalar quantity. Right? We have more vector quantities in the chapter like velocity, acceleration, which will actually depend upon this displacement. Okay, so hence the numerical value of a physical quantity is called its magnitude. Right? The motion in a straight line, the direction is simply shown as plus or minus. Plus or minus. Right? Getting my point? Minus. Why? Because the direction changes. Very good. Scalar and vector quantity cleared to us. Moving to the next step, that is average speed. The best example which we can see. Now you were studying, sitting on your study table like this. Just holding your copy, thinking about something, daydreaming. Daydreaming, it happens a lot of times, but suddenly you heard voice. That is your mother screaming at you. What you are doing? You have exam tomorrow, and what will happen? Suddenly, your speed of flipping the pages will increase. You were sitting on the same study table, but your speed is different at both interval of time. Right? I'm just giving you a rough example. We will understand speed in a more proper way here. So beta, what is speed actually? ठीक है? When we calculate speed, it is total distance traveled upon time. Total distance traveled upon time. Like there are days when you go to school by walking, but now today you were not in mood to go school, right? You're walking very slowly, right? It is just 100 meters away, but it took 10 minutes to you to reach to the point B, that is your school. You were very slow, but now you have an exam today, right? You have an exam today and your school is around 100 meters away and you are not left with a lot of time. You need to talk with your friends and revise everything. What will happen suddenly? Your speed will increase and it will be covered in just 2 minutes. To find the actual speed, what is the definition? It is basically total distance traveled upon time. Like this is in meter and hence we will calculate it in seconds. Getting my point? The same goes with this. You covered it in 2 minutes, bhai. So 100 meter upon 2 into 60. Obviously, this is the fastest distance covered by you. Okay? We will calculate this a uniform motion in a straight line, equal distance in equal interval of time for all possible choices of time interval. The object moves at a constant speed. Now what is this by? So whenever the person moves in a uniform motion, like for example, you are at point O, right? You started riding your cycle and reached to the point A. This point is 1 meter, just 1 meter away from your original position and you took 1 minute to cover that. Okay? Now you took a pause there, but again you started and moving towards point B in the same time, so the same distance is covered by you. You know what you are doing? You are at a constant speed. You are at a constant speed at all the intervals of time. But there can be times when you started moving a little fast from point A to B, and that is known as non-uniform motion in a straight line. Non-uniform motion in straight line. Bacha, we are right now studying motion in straight line. There are 3 types of motion, but you are not going to study everything in class 9. Majorly what you will study is motion in a straight line. So since distance traveled has no direction, now we are talking about direction anyway? No, you are just moving in a straight line. Average speed also has no direction. Right? What is the definition? What is the formula of average speed? By distance upon time. Now distance itself is a scalar quantity. It do not talk about what? Direction. It only and only talks about magnitude. How much distance is covered. They are not talking in which direction you have covered. Where did you reach? No. They are asking you how much distance has been covered, and hence average speed is also a scalar quantity. It is also a what beta? Scalar quantity. So what is average speed? Distance upon time interval. Distance upon time interval. Now as new SST books, new science book, new maths book, all of them has been made a more Indianized one. Let's talk about the topics, these same topics which up till now was taught in a way that the Greek people, the Roman peoples have developed. Let us understand that yes, in Indian books also the concepts were present, right? See, so there is a problem. There are 2 postmen started walking towards each other from a distance of 200 yojnas. Now what is yojnas? This was the unit of distance used in our ancient text, right? So there is a postman bacha A, right? And the postman B. The distance between these postmen is 210 yojnas. How much it is? 210 yojana. This is the actual distance. Now there are 2 people started moving towards each other. One travel 9 yojana per day. Right? This person A is traveling 9 yojana in a single day, one day. Okay? 9 yojana in a single day. The other one is quite lazy like you. Okay, so the other one starts moving and move 5 yojana in single day, right? Towards each other. Towards what? Each other. Now the question will be, in how many days will they meet each other? Will they meet each other? Now think about it, right? Think about it. How much is the total distance? Or how much is the total distance? Okay? So the total distance is 210 yojanas, right? What is basically their speed? Okay, so one is covering beta 9 yojana per day, the other is covering 14 yojana per day. That means in a single day they are covering 14 yojana, right? 14 yojana. Now how much time, right, they will take? Okay, how much days they will take to reach to each other? Right, getting this point? So basically it will be like this. See, distance covered by both in one day is 9 plus 5, that is 14. Time will be taken to reach to each other will be 210, that is total distance upon what? Per day time, that is 14, and it will be 15 days to meet each other. It will take how much beta? 15 days to meet each other only when they remain at a constant speed. Okay, only when they reach at a or they remain at a constant speed. Get it? Okay. Let's talk more about this. However, these yojanas and several units were written by Aryabhat, right? There were ancient texts which talk about the mathematics units, right? Great. Now moving towards next concept, that is velocity. Beta, there are two concepts we learn, that is distance. Actual distance covered, right? The total distance covered from position A to position B. Okay, then we reached beta displacement, the net distance covered in an interval of time to reach from his initial to the final position, the net distance or the shortest distance. Fine. So when we were studying about distance, we got about one more phenomena, that is average. What you studied, why just now? Speed. Okay, average speed. What do you mean by speed? So speed is distance upon time. Both of these are scalar, what? Scalar quantity, because neither this talk about direction nor this talk about direction. Both of them only and only discuss about the magnitude, that is number. Now, but there is a concept related to displacement, that average velocity. That is what beta? Average velocity. Average velocity, at which velocity the person is moving. Right? Here velocity which is represented as V. Abhi right now it is V. Later I'll tell you how it becomes U and V. Okay? It is displacement upon time. It is displacement upon time. Let's see this example. A person in a swimming pool starts from the point O. Right? This swimming pool distance is 25 meter. Reach at the point A. The person reaches to the point A. Okay, you know that the same person come back and reach to the point 0 at what velocity? Or I can ask what can be the speed, but speed is going to tell only about distance, right? Here the direction of the person changes, and hence the terminology will not be average speed, the terminology will be average velocity, because what has been changed here? The direction of the person has been changed here. Right, see beta, displacement upon time taken, that is S upon T. So Sarang took the distance of 50 meters to swim from one end to, it is time. So the Sarang person took 50 seconds to swim from one end of the 20-meter pool to the other end and back. So from position O to A and A to again O, the total time taken by this person is 50 seconds. Quick. Right? Now when I talk about the distance covered, and this is obviously 50 meter, but a question to all my students right now. What is that? How much is the displacement, right? What is the difference between his initial position to the final position? 0. Because he reached to the same point. So when I will ask you what is the average speed of the person, you will tell, ma'am, total distance upon time. What was the distance beta? 50 meter in 50 seconds, 1 meter per second. Right? 1 meter per second. The SI unit will become 1 meter per second. I will tell you how. When we talk about velocity, bhai, displacement is 0. 0 upon 50 becomes 0 meter per second. Why we are writing velocity and speed in meter per second, beta? When it is speed, what it is? It is distance upon time. It is distance upon time. Now distance is calculated in meter, time in second, it will become per second. Okay? The same goes with it, displacement. Okay, displacement is also measured in meter and time in seconds, and it will be meter per second. The question can come as kilometer and hour also. You have to convert it in meter and okay, get it? Chalo, cool. So we cleared certain topic. What is that? Distance, displacement, write the difference between scalar quantity and vector quantity, and then about what? Average speed as well as average velocity. Again the question will come for 5 marks. Write difference between, I hope everything is clear to you, right? Write difference between beta what? Average speed and average velocity. Average speed and average velocity. So average speed comes from distance, total distance traveled. It tells us, it depends upon what, beta? Total distance traveled. However, average velocity depends upon total velocity travels. As distance is the scalar quantity, this also becomes a scalar quantity, telling us only about the magnitude, no direction. However, velocity tells us about the magnitude as well as the direction. Right? 0 while still moving. Can distance be 0? Bhai, distance can never be 0. You are moving and the total distance needs to be covered. If you started from this position, right, you are still there, you are at rest, you moved nothing, that means your distance is 0. Okay? Right? Getting my point? But displacement can be 0. How, beta? You are at a point A, 0, move to point A, come back to the point 0, and hence average velocity can also be 0. Can average speed be 0? No. Can average velocity be 0? Yes. What is the SI unit? Meter per second or kilometer per hour, depends. And average velocity, meter per second, depends. Right? Here, the average speed of Sarang in the pool was 1 meter per second and it was 0 meter per second, that is average velocity, because he reached to the initial point from where he started swimming. Done? Great. For motion in a straight line, average speed and the magnitude of average velocity are equal if the object moves in one direction. That is also very, very much correct. What does this line means? If Sarang start from point O and reaches point A, if Sarang is only moving unidirectional, that means in the same direction in straight line motion. Straight line motion. What will happen? He covered the distance of 10 kilometers swimming. Okay? The distance become what, bacha? 10 kilometer. Right? 10 kilometer, which is equals to displacement also here, because the initial position was this and the final position is A, which is equals to the distance. Okay. Similarly, when Sarang is moving unidirectional, that is in one direction in a straight line, what will happen? Similarly, the average speed can be equals to that of average velocity. Average velocity. Perfect? Okay? Cool. Moving towards further more topic. Check yourself. Now it is the high time we should practice the questions that is given in NCERT regarding these topics. Okay, so the first question is, during a family road trip. By the way, do you guys enjoy going to your family road trip or get bored by those? So it is in the initial times, now it is so much of fun. But what happened? Somewhere in between, your mummy will remember that on a sudden, like on a random day, you did not do your homework and she forget to tell your father. That will be the time she will be telling. I don't know why. During a family road trip, you drive 200 kilometers north in 3 hours. So, okay, you are a person A, okay, driving in your car, which I am going to make very bad. Okay, driving in your car, you started heading towards north direction. You covered the distance of around 200 kilometers. In how much time, beta? Kilometers in 3 hours. Okay, 200 kilometers in 3 hours. Okay, now then 200 kilometers south in the 2 hours by same direction. Opposite direction, north and south. Now you started heading towards south. However, you covered the same distance, that is 200 kilometer, but this time little faster in 2 hours. Little faster in 2 hours. So find the average speed and average velocity for the entire trip. So what do you have to find in this particular numerical given is, beta, first you have to find the average speed, okay? Speed, and then you have to find the average velocity. So what is the average speed, beta? Average speed is basically distance upon time. What is the distance here? See the distance here. Okay, the distance is 200 kilometer plus 200 kilometer, that is 400 kilometers. Covered in what time? But it is covered in 3 plus 2, that is 5 hours. That is 5 hours. So basically your speed will be 40 kilometer per hour. Okay, kilometer per hour. But when I talk about velocity, you started from this point, headed towards north, and then came back at the same point in the southern direction. That means your displacement is what? 0. And when average velocity is counted, it is displacement upon what? Time taken. Displacement is 0, time taken is however 5 hours, and hence it will become 0 kilometer per hour. 0 kilometer per hour. I hope this is pretty clear to you. Okay, chalo, let us move towards the second question. Under what condition is the magnitude of average velocity equals to average speed? What condition your average velocity will be equals to average speed? By there is only one condition. The magnitude of average velocity is 0 while the average speed is not 0. Okay, they have asked you 2 questions. First we will write about the first one. Beta, when your object is moving in same direction, like the object was at point 0, moved towards point A. Now tell me the average speed. Average speed, like for example, you covered the distance of 2 meters in 1 second, then what will be your speed, beta? 2 meter per second. Okay, 2 meter per second. Same will be your what? Velocity too. And hence this is the time when you are moving in the said direction. But when the object returns to its starting point, say you come back to the original point again, your displacement will become 0, and hence your velocity will also becomes 0. Okay? So your displacement is 0, and hence average speed and average velocity will be different. Okay, hope this one is also clear. Next, a shop is 250 meter away from your home. Why I never go straight to the shop, right? You know that I remember this. I don't know your mother have the same habit or not, but I remember that since when I was child, right? Every time my mother used to just ask random things so randomly, and I always ask her that why don't you make a list in prior that these are the items to be needed. And the mehmans, guests are going to come, we don't have this, go and bring it. So at that time when guests were about to come, I was going straight to the shop, coming back to the shop. But when there was no such pressure, I was just taking a circle, reaching to the shop, coming back with a circle, chilling and talking with my friends meanwhile. So here's a question regarding that. A shop is 250 meters from the home along a straight road. So your house is here, your shop is here, and the road is straight. How much distance is there? 250 meter distance is there. Fine, by your father walks there. Now here the example is of father, by the way. So your father started walking from point A to point B. Okay? Now he remembered that, my God, I forget my bag. Chances are very low, however. But he realized that after reaching to this position that he forget his bag and walks to the shop again and come back home. ठीक है? So he started from here, went to the shop and then came back again. Twice the same distance is covered. Find the total distance. By total distance, arey no, I missed something. Okay, wait. A shop is 250 meters from the home along the straight road. Your father walks there. Your father reached towards the shop. ठीक है? Returns to your house because he forget the bag. Walk to the shop again. Okay, and then came back home 4 times. 250 into 4 times, then the actual distance covered by him is 1000 meter. What is the displacement? He is sitting at your home watching the TV and irritating you with a loud voice, and this will be 0 displacement. This will be what? Displacement. I'll give you a homework. Average speed and average velocity, find for the same. Average speed and average velocity. Quick. Do it in your copy right now. Take a pause. Do it in your copy. Tell me in the comment section. I will be waiting. Next is, a student runs from ground floor, ठीक है, to the 4th floor. Okay. Student runs from ground floor to the 4th floor. 1, 2, 3, and he reaches to the 4th floor. Then comes down to classroom on the 2nd floor. Comes down to the classroom on the 2nd floor. Each floor is 3 meter high. भाई थोड़ा बड़ा बनाएंगे. So each floor is 3 meter high. Okay. So here is a person. Let's make it here. ठीक है. You are living at ground floor. Oh, ठीक है. A first floor. अच्छा 1 2 3 लिखते हैं ना भाई. So it is first floor, 2nd floor, 3rd floor, and we have 4th floor. So a person started walking, right? And each floor is how much, beta? 3 meter. So first he reached to the 4th floor. That means he covered 3, 6, 9, 12 meter. ठीक है? Plus now he reached to which, beta? 2nd floor. Came back and covered 6 meter more. How much total distance the person has, the student have covered? It is 18 meter. What was the first question? Find the total vertical distance. Done. Now find the displacement. Bhai, the person is at point 2. So the final position at which he is standing is point 2, which is 6 meter away from the original position, and hence your displacement will become 6 meter upwards. It will become what, my dear student? 6 meter upwards. Okay, so distance, displacement, speed, velocity, done, but not dusted. Keep it in your mind. Now coming towards next thing, that is average acceleration. Now what is acceleration? By acceleration, for a long period of time I just knew one thing, that is accelerator in the bike. Then later I got to know about accelerator in car. Okay, but now being the teacher, the definition of acceleration for me is different. But a lot of times we have noticed that, okay, that whenever the car starts suddenly, right, we feel a jolt. We come little right towards the like front. The same you noticed whenever the brake is applied in the train. The same you noticed sitting on a bicycle. ठीक है? The same you will notice when a bus will start. What is that? Is it because of acceleration? Because at that given interval of time there was change in speed. What was it? Change in speed. From where we started, distance, displacement, speed, velocity. Now we are moving towards acceleration, right? Then change in speed. So beta, the jolt you feel when a vehicle starts or stops suddenly, it is acceleration, and it is calculated by change in velocity. Change in velocity, because acceleration not only talks about distance, or what we can say, not only talks about magnitude, but it also talks about direction. It also talks about direction. ठीक है? So it comes from change in velocity upon time taken. Changes velocity upon time taken. But to understand this concept, we have to understand certain points. Right? What is certain points? Beta, change in velocity. Again, what is this? So, right, you are sitting in a car, right? You are sitting in a car. First you were in uniform motion. That means the same speed was going on. Suddenly your father pressed the accelerator and the speed increased. The car is speeding up. Okay? The car is speeding up. Velocity is increasing. Speed upon distance increasing, and hence is the acceleration will increase. Okay? You will feel that jolt. When the car will slow down again, the velocity will increase. Okay? But the acceleration will decrease. Now what is this? Direction of average acceleration when magnitude of velocity is increasing and decreasing. What is this concept? We will understand just in some time. Right? What is this? Velocity increasing, acceleration increasing, velocity increasing, acceleration decreasing. Beta, it depends upon certain factors. See, magnitude, that means number of velocity is increasing. Acceleration is increasing in the same direction. When you increase the speed, that means velocity, right? It will be like acceleration will be positive. Acceleration will be positive. Example will clear everything to you. But now what happened, beta? When the magnitude of velocity is decreasing, that means you are decreasing the speed. Acceleration will also go in the negative, what we can say, direction. Before moving to this concept, which is not clear in your mind yet, I will tell you the SI unit. Remember, what is average velocity? Okay? So it is displacement upon time, yani ki meter per second. Now, what is acceleration, beta? Average velocity upon time. And hence, the unit, SI unit of this will become meter. Okay? Ma'am, first please clear this concept. Here is the concept. Okay. So, now, you're heading toward your school in this bus with no mood to go to school, but anyhow you have to go. So you're sitting in this bus, beta, and when you're sitting in this bus, you were moving at an initial velocity of 36 km per hour. That means, right, that means the speed of your bus in the time interval was 36 km in per hour. Okay? The speed was 36 km. How much time? Per hour. And hence, your velocity was, upon time, it becomes 10 meter per second. Okay? In 1 second, how much you were moving? Just 10 meter. Okay, fine, beta. But now, suddenly, the bus driver pressed the accelerator and your speed increased. Speed increased to 54 km per hour. 54 km per hour. Don't you feel there is change in velocity? Right? There is change in velocity. Yes, there is change in velocity. Right? What is acceleration? Acceleration is actually change in velocity in the interval of time. Initially, it was what? It was 36 km per hour. That means 10 meter per second. And now it is 15 meter per second. How you will find the acceleration, beta? Final velocity minus initial velocity, where V is final velocity, U is initial velocity, V minus U. That is 15 minus 10 divided by the time. Divided by the time, that is 10 meter per second. And hence it will become 0.5 meter square minus 2. Okay? Now, moving to the next one. When brake was pressed. So now, you were in more speed. See, I'll tell you with the help of graph. So, you are at a point 0. You are at a point 0. Now, what happens? You were moving at a constant speed. Okay? Constant speed. That was 10 meter. How much meter, beta? This is 10 meter. 10 meter in a second you were moving in this speed. Now suddenly your bus driver pressed the accelerator and your speed increased. Your speed increased. For a period of time, now you are moving at a increased speed, that is 54 meter per second. After this, the person now press the brake, right? Press the brake, and your basically your gadi or your bus now moved to what? 0 speed. Don't you feel there is change in the graph? Yes. And that change can be understood by this acceleration. During this time, accelerator increased in the positive direction. However, during this time, the acceleration, see, there was change in displacement and hence the velocity change. But the acceleration here becomes what, beta? Negative. It becomes negative because the final velocity reached 0. Final velocity reached at which place? 0. Getting my point? So when brake is pressed, the original velocity was 54 km per hour. That means 15 meter per second. The final was 0 meter per second. The time taken, right? The time took to cover this brake was 5 seconds. How much, beta? 5 seconds. Here is the time. So A is equals to acceleration equals to final velocity 0, initial velocity 15 upon time. 0 minus 15 minus 15 upon 5, and hence the acceleration will be negative. Acceleration will be negative. Acceleration can be negative here. Okay, right? We have one more example from the example of an object drop from a height. So now, see, this is the example given straight from your NCERT, taken straight from your NCERT. There is an object with a height of 80 meter, over the height of how much, beta? 80 meter. Now, consider you are standing at a height and you drop the ball from your hand. Right? Consider that you dropped the ball from your hand. So now what will be the speed? What will be the velocity? What will be the acceleration? This is how what we have to understand. But when the object is dropped, the initial velocity, because it was at rest at that time, and hence the initial velocity becomes 0 meter per second. 0 meter per second. The time was also 0 second. But after 1 second, as it is given in this picture, after 1 second, beta, the average velocity of that object was 9.8 meter per second. How, bhai? Because of the gravitational pull, the object started moving downwards. When it moved towards second, what happened? It doubled, because in 1 second is covered 9.8, in 2 seconds it will cover how much? 9.8 into 2, and it becomes 19.6. The same goes on and on for 3rd second, 4th second, 5th second, 6th second. But now the question is, what is average acceleration? What is average acceleration of that object? So beta, when we have to find the average acceleration of that object, it will become what? Final velocity upon, right? Sorry, final velocity minus initial velocity upon what, beta? Time. We know that we are representing final velocity as v minus u upon t. So now let's calculate for each of the second. So when the object was at 0 second and moved to 1 second, what is the acceleration? Final velocity 9.8 meter per second minus 0 upon time taken 1. How much does it becomes? It becomes 9.8 meter square s minus 2. Okay, now the next goes with from 1 second to 2 seconds. So 1 second, what was the here initial velocity? Initial velocity, it becomes 9.8 meter per second. Final becomes double, that is 19.6. Again, how much is the acceleration? 9.8. The same goes for 3rd second, same goes for 4th second. But here it is very much clear that when the object will be dropped from a height, its velocity will obviously increase. But the acceleration here remains constant, because the gravitational pull is same for each time of interval. You know that here this gravitational pull is denoted by small g in this case, right? There will be lot of numericals that can be asked on this basis, where you have to find the average acceleration of an object. So whenever an object will be dropped from a height, beta, its velocity will increase. See here, apply the motion, apply the law of motion. Is there any external force applied to hinder or change the velocity? No. And whenever there is no external force applied, there will be no change in the acceleration. Getting my point? Getting my point here? Okay, great. Now we are moving to some of the next topic. Again, they are numericals which are given in your book. State from the book, which we will practice fatafat. So a girl riding her scooty finds that the speedometer reading is constant. Okay. It is possible for her scooter to be accelerating, and if so, how? See, a girl is riding the scooter and finds that for a long route, her speedometer is constant. One case is that she might be moving from the straight road, but there is no such case given here. So there are chances that she might got turns, she might got change in direction. So beta, the speedometer can be constant whenever there is change in the directions. Change in direction, she might be accelerating, but because of the change in direction, for example, she was going straight, speedometer was same, then she got the turn. When she will get the turn, the speed will eventually drop down, and to maintain that speed, she will give accelerator, but again the speedometer will show the same magnitude because of what? Because the direction changes here. Okay, get it? Chalo. Next question. A bus moving at 20 meter per second. Bus is already moving at 20 meter per second is brought to rest in 8 seconds. Brought to rest matlab brake laga diya. Okay, applied the brake. So here the initial velocity becomes 20 meter per second. Right? When the object comes at rest, the final velocity here becomes 0. Okay, and the time here becomes 8 seconds. So beta, according to the formula for acceleration, what is average acceleration beta? Average acceleration, change in velocity upon time, v minus u. So v is 0, minus u is 20, and upon 8. What you are going to get is the answer in negative 2.5. Why beta? The minus sign, right? The minus sign show here that it has been moved in opposite direction to that of velocity. Opposite direction to the velocity. Get it? Okay, next question. A truck moves along a straight highway at a steady 60 km per hour. Steady, there is no change in any speed. Okay? For half an hour. What is the acceleration? Does a large speed means a large acceleration? Beta, pay attention. Let me clear this to you with the help of a graph. Right? On x-axis, we will calculate time. However, on the y-axis, we will calculate the speed. So this is the speed, that is 60 km per hour, which is covered by truck constantly for half hour. This is 1 hour. Okay. So the truck is moving constantly with the same speed for half hour. Right? Will there be any change in the acceleration? No change in the acceleration. Why? Because here the initial velocity was also 60 km per hour. The final velocity is also 60 km per hour upon the time taken, that is half hour. Okay, it is just an roughly done. What will happen? 60 minus 60 0, and an acceleration will becomes what beta? 0. The velocity does not change, acceleration depends upon how the velocity change. If here there might be any change in the velocity, will create the change in the acceleration too. Done. Now we are moving to graphical representation of motion, right? I left one example in the previous slide because you will learn that with the help of these graphs. Why we are moving towards graph in physics? It helps you to compare the motion of two objects at a glance. But up till now, the concepts we have read, taken the example of one single object. But now there is not only single object moving, there might be multiple objects and we have to compare them. We have to calculate their exact physical quality and classify them. So what we have to note before we are starting, all graphs in this chapter are for motion in straight line in one direction only. This is very, very important because in class 9th you are just understanding motion in straight line. Okay, in this case, in this special case, distance, magnitude of displacement and speed is equals to magnitude of velocity. Okay, fine. let's move to the graph. So whenever we talk about graph, beta, I will tell you some basics about graph. However, I am just assuming that you are well aware about what graph is and how do we mark points in the graph. Okay? So we'll buy this graph for solving some questions of physics, in which beta we divide the graph into x-axis. Okay? The vertical lines in x-axis, the horizontal lines in y-axis. You have to mark the original point x here and y there and 0 here. Okay? Basically, majority of times we will be calculating time at x-axis and position of the object at y-axis. Okay? Position of the object at y-axis. Okay? Now, here one example is given. Here one example is given about beta an object. Here one example is given about an object which is moving. The movement is such that in 1 second it covers how many meters beta? 20 meters. In 2 seconds it covers how many meters? 40 meters. Okay? Then in 3 seconds it covers 60 meters. So how we are going to mark this map beta? See, what we will do, we will divide the equal graphs into certain seconds. Like this 5 lines calculated as 1 second, 2 second, 3 second, 4 second, 5 and then 6. The same goes with the meter. So in 1 second it covered the distance of 20 meter, mark a circle here. 2 second it covered the distance of 40 meter, mark a circle here. In 3 second it covered the distance of 60 meter, mark a circle here. And the line we will get after joining all these points will be actually your graph telling us how the object moves in a straight line. How the object is moving in the straight line, just a brief. Okay? It is not the route map basically. Mind this word here. This is not the route map that the object is moving in this particular direction only. Okay? So it is just giving you a straight line motion example. Here is the correct way which we can understand. So the points do not fall in a straight line here. You can see. Can you see that? Yes. Why? Because here the change in speed is happening. The velocity here is not same. See the table number 4.4. So at 0 second the object was at 0 minute. Here is the object at 0 second. Right? After 2 seconds, the object moved to 1 meter. So after 2 seconds, beta, see what we have done. 2, 4, 6, 8, 10, 12. We divided the x-axis into this, right? Then y-axis into 5 meter, 10 meter, 15, 20, 25, 30 more. Okay. So 2 seconds, the object at the 2 second, the object was at 1 meter. Here is 1 meter. This is 5 meter. So 1, 2, 3, 4, 5. 1 meter. After 4 seconds, the object reached to 4 meter, right? 4 times the speed has been increased. So after 4 seconds, it moved to 4 meter. After 6 seconds, it is at 9 meter now. Okay? It is at 9 meter. Can you see that the difference in the distance is changing after an interval of time? Is it constantly changing? No. Right? The difference is not constantly changing. 8 seconds it reaches to 16 meter. 10 seconds 25 meter speed has been increased. 12 seconds it reached to 36 meter. Here the graph that is formed is not in straight line. There is a curve, that means velocity is changing. And when the velocity is changing, the motion is accelerated. The motion has been accelerated. Right? Getting my point? Velocity changes, motion accelerates. Okay. Position time graph, what the shapes tells us. So here, okay, whenever the graph will be in straight line, okay, whenever the graph will be in straight line beta, so what will happen? In equal interval of time, the displacement was also equal. For example, in 1 second, the object moved to 20 meter. In the next second, it will move to, for obviously, next 20 meter, that is 40 meters. Whenever in the graph, we will get the straight line object will be in what beta? equal displacement, and hence the constant velocity is found. But here when the graph is not in the straight line, it is a curvy linear shape, beta, it is changing velocity. The velocity is changing because the displacement is also changing at an active interval of time. Very easy, this you can understand. Now with the help of these graphs, let us understand more how to calculate them and what if the question comes likewise. Because beta, these graphical representation are not given for your fun and activity time. The questions can come straightly from here to find about initial velocity, final velocity, distance, displacement, etc. etc. Okay? So let us take the example that beta, the object, right? The object is in straight line motion. The object is in what beta? The straight line motion. At 1 second it reached 20 meter, 2 second reached 40 meter, 3 second reached 60 meter, 4 second reached beta what? 80 meter. Now with the help of this graph, join the adjoining lines here. Join it like this. You can see this is the triangle being form. This is a rectangle being form, isn't it? Okay. Again here is a triangle being formed. So now what these shapes represent us and how does it help? So the BC represent the change in position, that is S2 minus S1. How beta? C. BC. So can you see here? Okay. So this was an object at 0 first, right? It moved to point A. It moved to point A at time that is 2 seconds. Get it? It moved to point B at the time that is 4 seconds. So at 4 seconds we are considering it as T2. At 2 seconds it is marked as T1. Okay. So the change in time will be T2 and T1. Now let us move to the position. It was first at the position A and second at the position B. The position B is S2. The position A is S1. Now BC represent the change in position from S2 to S1. Okay? So what is BC beta? This BC basically tells us about S2 minus S1. And what is AC telling us? By time difference, T2 minus T1 will be the actual distance, like 4 minus 2, 2. And this is what the difference here is 2 actually. So AC represents us change in time. However, the BC represents us here the change in position. Now coming to the question, beta, that is if we need to find the velocity. Right? If we need to find the velocity of the object moving from one position to another, so it will be what? Change in displacement, right? Change in displacement upon what beta? Time, upon time. So can we calculate this? S2 minus S1 upon T2 minus T1. Okay? Now what is S2 minus S1? Is it BC? Yes, it is BC upon what beta? AC. Okay? It is BC upon AC. Getting my point here? This is the slope of position time graph in a straight line motion. If we substitute it, then you will get the correct answer. Like V equals to, so how much is S2? 80 meter. What is the distance covered here? 80 meter. What is the distance covered at C? 40 meter. Time taken at T2, that is 4 seconds. Time taken at T1, 2 seconds. If we calculate it, it becomes 40 meter upon 2 seconds, and hence the average velocity for an object moving from point A to point B becomes what? 20 meter per second. Okay? 20 meter per second. Easy. But now what happens? Because see, in the last graph beta, the velocity, what happens? The velocity, or what we can say, the displacement was changing and hence the velocity. But when an object is not changing its speed, not changing its speed, at 0 time it was at 40 meters, at 3 seconds it is at 40 meter, at 4th second it is also at 40 meter. The position of the vehicle is 40 meter from the origin and is not changed. That means what we are going to consider, the object is at rest. Right? When the object will be at rest, what about velocity? It will also not change. So the position time graph for an object in motion and for an object at rest is different. Now coming towards two objects, comparing how many objects? Two objects. So there is an object A which started from point O, origin point, and moved towards this point beta. Object B moved towards this point. The graph of both is considered different, obviously. Okay? Now join all the parallel lines because we have to compare the displacement of two objects from the position time graph. Beta, you can clearly see that the same time interval, okay? For the same time interval, this is also at the same time and this is also at the same time. Okay? I am taking at 1, 2, 3, then 4. So after 3.5 seconds, okay, after 3.5 seconds, both the objects at the same time reach to different places, at different height. Why? The question is why? Because the displacement of B is more than that of A. Right, can you see that? They both started from 0. After 3.5 seconds, object reached here, but B reached here. Why? The distance clearly indicates that the displacement of B is more than A. So the slope of line B is steeper than the slope of A. Hence, whose velocity must be higher? Whose velocity must be higher? Who is far away? Whose slope is steeper? B. So the velocity of B is obviously higher than that of A. Okay, what does the shapes tells us? Basically, this is the question. So here beta, here the shape of the graph in which the object started from same place and reached to this and is at the same place only. Okay, here it will be constant velocity. But when you move to this graph and you can see that there is a straight line graph of an object's movement beta. At active interval of time, velocity is increasing, right? Velocity is increasing, but by equal, what we can say, but by equal manner. And when after interval of time, velocity is equal, what will happen beta? The acceleration here remains constant. The acceleration here remains constant. Okay? Next is this graph. Now this is known as retardation. This is known as what? Retardation. Why? What is happening beta? At zero time, which is the initial time beta, the object was at the speed of 15 meter per second. At the velocity of how much? 15 meter per second. But then the speed is started dropping. 12.5 meter per second, 10 meter per second, 7.5. By acceleration, what will happen to acceleration? Velocity. Now, don't think that the acceleration will go negative. No. Velocity is what beta? Decreasing. Velocity is decreasing for obvious reasons. Okay? Velocity is decreasing, but the velocity is decreasing equally after intervals of time. Again, see, after 1 second, how much is dropped? Minus 2.5. 1 second, how much is dropped? Minus 2.5. Can't you find this as equal? Yes, and hence the acceleration here is also constant because of equal interval of time. Okay? Now, slope of velocity time graph provides us acceleration, but how to calculate us? From the recent graph, you are very much clear that either the velocity is increasing or the velocity is decreasing, but at equally at intervals of time that the acceleration becomes constant. But what happens when the question comes? So beta, see, A is equals to BC upon CA. This we have figured out previously. So BC is basically change in displacement and this is the change in time. Okay, change in time. Here, this is not displacement, sorry. This is change in velocity. Okay, when the object moved at, okay, I'll tell you from starting. So, it is 0. Object started moving. After 10 seconds, with the speed of what? The speed of 5 meter per second, it reached the point A. Then after the speed of the second object, after the speed of what beta? 10 meter per second, reached to the point B. So, now what is the difference between the same? what is the difference between the same, it will be calculated with the help of this BC. However, the time will be calculated T2 minus T1. So, beta, acceleration equals to change in velocity upon change in time. Change in velocity upon change in time, that is BC upon CA. If we calculate it, in this case, the acceleration, what was the time, beta? What was the velocity? 10 meter per second minus, okay, 10 meter per second minus 5 meter per second. BC, okay. Then let us find CA, that is T2 minus T1. What is T2 minus T1, beta? Here T2 is 20, T1 is 10. What we will get? 0.5 meter per second square. Okay. Okay, getting my point here? So it will be positive in the case when velocity is increasing. But when velocity is decreasing, the answer of the acceleration becomes negative. How? Let us find that. So what is acceleration, beta? Change in velocity upon time. The object was first at how much, beta? 15 meter per second. Okay? But then it reached to what, beta? 0 meter per second. 0 meter per second. Final velocity upon minus initial velocity. Okay? Upon time taken. How much is the time taken? 30 seconds is the time taken. 30 by, it will be equal to minus 1 upon 2. That is minus 0.5. And this is how we calculate what? Acceleration. Okay. When velocity is increasing, okay, acceleration will remain constant but in positive. Here there is retardation, it will become negative because direction is changing. Because what? Direction is changing. Okay, so now we will learn how to find area under a velocity time graph, that an object covered how much area. Okay? So there are two cases. Case number one, when the object was moving at a constant velocity, that means at the 0 point, that is point of origin, the object was at 20 meter per second velocity. However, after a time interval, that is 6 seconds, the object was again at the same velocity, that is 20 meter per second. Now, in that case, beta, with the help of these graphs, we can see, this is the graph where velocity and time is being shown, and the area covered is actually equals to a rectangle when the velocity was constant. How to find that area? Obviously, that area of rectangle OACD, because we pointed O as the origin point, C as the time, B as the position where object has reached, and A the position where object is started, OACD, right? So OA here becomes what? OA into what, beta? OC, okay, into OC. So what is OA here? 20 meter per second into how much time it has taken? 6 seconds it has taken. So how much meter, beta? 120 meter is the area covered by an object. But what if in case the object is moving with a changing velocity? For example, object started at a point O. After 10 seconds, it reached to the point A. How much velocity was it? 5 meter per second. After interval of time, that is 20 seconds, it reached to the point B, and that is 10 meter per second. In that case, the area will be the total of this triangle as well as the rectangle. Okay? How to calculate? Because beta, in this case, however, the velocity was changing, but the velocity was same after intervals of time. See, same change in velocity. Okay, 5 seconds, 2.5, next to 5 seconds, 2.5, next to 5 seconds, again 2.5 meter per second. And hence, the change in velocity was there, but the change was constant, and hence acceleration becomes constant here. But how to find the area? Beta, here area will be, see, this point ABC creates a triangle. Okay, so it will be area of triangle ABC plus area of rectangle, that is EACD. EACD. Now you know the area of triangle, that is half base into height, plus what we have to do, plus this length into breadth of this rectangle. When you calculate, you will find that the area covered in this is 75 meter. Please do the calculation right away. Okay? Now we have to check ourselves more that did we get the graphs of motions or not. Right? First question. A velocity time graph is a straight line parallel to the time. So beta, with the help of graph. Okay, so this is the velocity, because the question says velocity time graph, and this will be the time on x-axis and velocity on y-axis. Okay? Now the question says that beta, it is parallel to the time axis at 12 meter per second. It is parallel. So when it was at 0, the point of origin, the velocity of the object was 12 meter per second. After interval of time, that is 10 seconds also, the object was at same velocity and reaches to the point B. Let's mark it as A. What happened beta? We have to calculate the area. How we will calculate the area? Area of rectangle as it is formed. Okay? The slope is 0 however. Okay, the slope is 0, but the acceleration is also 0 meter per second for obvious reason. The area covered will be 12 meter per second into 10 second, and hence it will be 120 meter. I hope you are getting the points. The next question, extra question for practice. Car stands from rest. Okay, so let us see this graph, x-axis, y-axis, because we are doing the questions of velocity time graph. Okay, so this will be velocity, this will be your time. The car starts from rest. Rest is 0. Okay, and reaches to 15 meter per second. It is what beta? 15 meter per second after 30 seconds. Let this be 30 seconds. Okay, so it reaches where beta? 15 meter per second. You can see a triangle being formed by this graph. Yes. So find the displacement over the whole 30 second. Displacement means beta, how much it has been displaced, how much area it has been like covered. So here the area of triangle will be half into length into this base into height. Okay, base into height. Calculate it. 225 meter will be the answer. Easy. So on a velocity time graph, what does the slope of the line represents? What does the slope? Whether the acceleration is there, velocity is there, it is accelerating or retarding. What does the area between the line and the time basically represent? That area which we were calculating represent the beta displacement over the interval of time. How much? What is displacement beta? How much distance have been covered, magnitude, plus in which direction, and that can only be understood or calculated with the help of this area in the velocity time graph. So actually the unit we are getting after this area is displacement. Now next, let's move to next topic. All the time I am leaving one numerical for you, right? After analyzing this graphs, right, there are certain equations which have been derived, which can make your further calculations easy if you know the cases. Okay, so this is the case. Okay, this is the case of an object which started from the velocity at u. Okay, see, let's analyze this very nicely beta, because it is going to help you to derive the numericals in future. Okay, case is that beta, this is velocity time graph where the initial velocity of an object is not 0. It has not started from 0. Okay, the initial velocity of an object is considered to be as u. After the time interval, that is t, it reached to the point that is b. Right? When it reached to the point, the velocity is v. We don't know the number just for derivation. Okay? It becomes what beta? V. So you have what? You have beta initial velocity. Okay? What was the initial velocity when object started moving? It is u. What becomes the final velocity when object reached to the point B? It becomes v. What is the time taken for an object to move in this manner? That is t. If I ask you to find the acceleration, what will happen? The difference in the velocity upon time, final velocity minus initial velocity upon time. So A will be equals to V minus U upon T. Right? Can we make this T here and it can be written as AT equals to V minus U? V minus U. Can you write it as beta? When U reaches here, it will be V. V equals to U plus AT, and here is your equation number 1. Your equation number 1. Whenever in a question, final velocity, initial velocity is given, as well as the time is given, will you able to find the acceleration? Yes. Whenever in a question, initial velocity, acceleration and time will be given, can you find the final velocity? Yes. In a similar way, right? In a similar way, when you are asked the displacement or the distance covered, right? How to answer that? Okay? So this is the displacement, actual displacement of the object, right? Plus this triangle too, because object started from initial velocity u and reached to the point B. This is the area covered by an object, which include the area of a triangle plus rectangle. So here S, okay, that is displacement, will be equal to the area of the rectangle OECD plus area of the triangle ABC. Now please calculate this very nicely, beta. Calculate it very nicely. See, so S equals to area of OECD. Where is OECD? OACD. Length into breadth. Okay? Length into breadth. That means, pay attention to this. That means, so here S will be equals to rectangle of the triangle OECD. Okay? OACT. Length into breadth. Here length is equals to T. Fine. Your breadth will be equals to what, beta? U. Okay? Plus half. Half what? Because now we have to add it with the area of triangle. Half into base into height. So base is AC, which is again T. And the height is BC, which is change in velocity. Change in velocity. Final velocity, actual velocity, V minus U. From the previous equation which we have figured out, beta, the value of V minus U is 80. Right? 80. So S equals to UT plus half T. 80. 80 into T, T square. S will be equals to UT plus half AT square. Hence, we derive the second important kinetic equation. The second important kinetic equation. From this beta, two equations, we are going to now figure out the third one. We are now figure out the third one. So, the first one is V equals to U plus AT. How did we figure it out? From this, to find the acceleration, it is what, beta? Final velocity minus initial velocity upon time, that is change in velocity upon time. We got the equation, that is V plus UT. From this, we got the displacement also by finding the area of that particular the region. The object has changed, right? That is UT plus half AT square. Now this one. Why this one? Because there might be cases when you don't know actually the time. When you don't know the time, beta, you will figure it out like this. So here it is T. Can we extract the value of T from it? Yes. V minus U equals to AT. Okay? Hence, V minus U upon A becomes T. So, this is what? The value of time. What if we put the value of time in this equation? See, to find the displacement when time is not given. Okay, so it is U. Fine. The value of T will be taken from here, that is V minus U upon A, okay, plus half what? AT square, V minus U upon A ka square. Okay? Now, how we have to derive it? Pay attention, beta. The S will become, okay, multiply it U V minus U square upon what? A plus half, ठीक है, plus half. Okay, so A minus B का whole square, it will become what, beta? U square u square plus v square minus 2uv, okay, upon में a का square because this is whole square. Fine, it's going good. S equals to uv minus u square upon a plus, ठीक है बेटा, this acceleration cancel. What is remaining is 2a u square plus v square minus 2uv. Now take the LCM, right? What will happen beta? This will be 2a, this 2 will multiply here. So here it becomes 2uv minus 2u square plus u square plus v square minus 2uv. This plus ka 2uv minus ka 2uv get cancel. Now what is remaining by? So what is remaining? S equals to minus 2uv, okay, plus ka uv, plus minus 2 minus 1. However, the sign will be minus ka, okay, 2 minus ka u square plus v square upon 2a. Can we write it as 2as, okay, equals to v square minus u square? Yes. Can we write it as u square equals to v square plus 2as? Yes. And hence, whenever the time is not given to you, velocity, both the velocity initial plus final plus the displacement is given to you, you can find the values. Any of the value when the time is not given. The 5 quantities where S stands for displacement, U for initial velocity, T for time, final velocity, acceleration. This you know, we are doing it from starting, but there are conditions. This 3 kinematic equation can only be valid when the acceleration is constant. What is constant beta? Acceleration is constant. That means the change in velocity after interval of time is same. Okay, in straight line motion this is going on, ठीक है? Okay, in both the direction, when the direction is same, it carries the same direction. So these are certain conditions. Now coming towards the next example, that is braking distance, ठीक है? So the problem given in your NCERT is brake causes an acceleration of minus 4 meter second square, right? Minus 4 meter per second square. This is the acceleration. And why it is in negative? Because retardation is there. Brake is being applied. How far does the car travel before stopping? It was moving at 54 km per hour. Okay, good question. Or it is at 108 km per hour. So see, 2 cases are given to you when the speed of the car actually was 54 km per hour. Okay? The next time, the second condition they are giving when the speed of the car was 108 km per hour. Right? Now the another thing which is provided in both the condition is acceleration, that is minus 4. Right? That is minus 4. Now they are asking you कि if the brake is applied, so whenever we stop our bike, our car, right, when we were in speed and we stop it suddenly, it will move a certain distance. So actually the question is asking you how much is the distance covered by your vehicle when brake is applied. Okay, when it was at the speed of 54 km per hour, or the second case when it was at the speed of 108 km per hour and the acceleration is given to you. Take it easy. The question sounds to be difficult, but it is easy. Now in this case beta, actually they are asking you how far the car traveled. How far the car traveled, that means the distance is there, right? Now you know the acceleration, that means A is provided to you. Okay? You know that the final velocity when the brake will be applied will become 0. You are not aware about U. However, 2 instance of U is given to you, then means you should use the equation which have these particular points, and we just derived it. V square equals to U square plus 2as. Right? What it is beta? V square equals to U square plus 2as. What is the final velocity when brake is applied? 0 for obvious reasons. It becomes 0. Now it is U square. Okay, U square. And now what is this? Minus 4. What it is beta? Minus 4. This is actually acceleration. Okay, acceleration is negative. So plus 2 into minus what beta, minus 4 into s. ठीक है, it will become 0 is equals to u square minus का 8s. s here is displacement. Okay, s here is what beta, displacement. Can we write it as like this? ठीक है, can we write it as like this, that 8s is equals to u square, then s will become u square upon 8. Displacement will be what beta, u square upon 8. U is given to us in two cases, okay, when the initial velocity was 54 km per hour, but now it is in what beta, kilometer plus r, and hence we need to convert it into meter per second. Whenever the data is given to you in kilometer per hour, you need to convert it in meter per second, just divided it by 5/18 and vice versa. ठीक है, you get the number that is 15 meter per second. This becomes your final velocity. Just put it into the formula we just derived. S will be equals to u square upon 8. U square upon 8. The answer will be 28.1. Here u square is 15 square upon 8. 225 upon 8. 28.1 meter. And here the same is, just change it, 108 into 5 upon 18. You will get 30 meter per second. Right? Put it into this formula and it will be 112.5 meter. This is how you find the displacement, the case when your object was at velocity, right? Brake is applied with the acceleration of this amount. Okay, when these number is given beta, it will be helpful to you derive the numericals. Bringing science and society. Now the chapter we started that by whenever like two cars are moving, it is needed that as at a safe distance, right? For safety we need to keep the distance. Did you get it? Because whenever the car will stop, right, the distance covered by it, the distance covered by the car actually depends upon the speed of the car, depends upon the speed of the car or the velocity of the vehicle when the brakes are applied. Okay, and there may be chances the roads are wet, dry and so on, and hence the braking capacity also plays a role. Why the safe distance changes? Beta, the faster you are moving, the more distance you need. Okay, the faster you are moving, see, the second case you were moving faster and hence you need more distance. Okay, whenever your speed is double, you need more distance to cover after the brake. Okay, so the gap of the vehicle ahead must be adjusted to your speed. When you are increasing with the speed, please give more distance from the vehicle riding in front of you. Okay, so these were three kinematic equations on which the entire chapter is dependent upon. Now I would suggest you to solve this question. Check yourself if you are able to do it or not. Okay, first we will brief about them. A motorbike moving with initial velocity of 28 meter per second. Okay, so your value here of initial velocity becomes 28 meter per second and a constant acceleration stopped after traveling 98 meter. S is given to you, that is displacement 98 meter. Find the acceleration. What you have to find is beta acceleration. When you solve the question numerical in physics, first write always the given. Right? Write always the given. So, what is the initial velocity? U is equals to 28 meter per second. Acceleration here is asked. The displacement here is 98 meter. Find the acceleration and time taken. Time is also not given. So, which equation you are going to use when time is not given? V square equals to U square plus 2AS. And we know that as the vehicle is stopping, that means brake is being applied. So, the final velocity will become 0. Okay, the object will stop moving, will become at rest. Solve it, try to solve it. Next is a truck driver at 54 km per hour sees the speed limit sign. So the truck driver was already moving at 54 km per hour. Okay? Now he saw a signboard asking him to reduce the speed, and he decreased the speed to 36 km per hour in 30 seconds. Okay, so this was the initial velocity. Okay, that is the initial velocity. What is the final velocity? 36 km per hour. What is the time taken to reduce this? 36 seconds. What distance S is needed to be find? Right? So S equals to ut plus half at square. Solve it. Okay? Next is, a car starts from rest and accelerates uniformly. So the initial velocity was 0. Right? And accelerates uniformly. That means final velocity is 20 meter per second in 5 seconds. Time is how much, beta? T is also given, that is 5 seconds. Travel at 20 meter per second for 10 seconds, then brake uniformly to stop in 6 seconds. Find the total distance travel. This we have to understand very nicely. So see, let's understand with the help of a graph. A car starts from rest. Okay? The car was at rest and accelerates uniformly to 20 meter per second in 5 seconds. So 5 seconds, right, it reached beta how much? 20 meter per second. Fine. This is 20 meter per second. Right? For 10 seconds. So up till 10 seconds, the car was moving at the same speed. Okay? That is 20 meter per second. Fine, bhai. Then क्या होगा? Then it brakes uniformly to stop in 6 seconds. In the next 6 seconds, it has to brake. In the next 6 seconds, brake. And hence the acceleration, or what, not acceleration, but the velocity will decrease. Find the total distance traveled. Can you see that this is area of a triangle, rectangular, and then the triangle, right? Calculate it. A bus traveling at 36 km per hour sees an obstacle 30 meter ahead. The driver reacts in 0.5 seconds and then brakes at. This is also the same way. Try it, beta. If not, then we will do it. Motion in a plane. Now moving to the next topic, beta. There might be chance in the straight line motion also, like the car is moving in straight line, but now the car needs to overtake it. Don't you feel the direction is going to be changed? In that plane area also, the motion will be different. If we look at this, this is also known as motion in a plane, when you just kick your football. And the third one, that is the revolution around the earth. So beta, the satellite in a circular part is moving the path of a kicked ball, a vehicle overtaking the another. What happened in these 3 cases? All these 3 cases, beta, there is motion in 2 dimension. The motion is in 2 dimension because the car was moving straight and then the direction changed. Football reaches to the same point, but how? In this 2 dimension. The same goes when the satellite is circulating around the earth. What does it actually means? This is actually somewhere circular motion. This is actually what, beta? Circular motion. You know how to calculate the displacement as well as all these important things in circular motion? See, so this is a circle. Okay, you are a student, you are again asking to your teacher to come back from washroom. Now you're not going straight as usual. You will take the circle of the school and reach to the point A, right? Reach to the point A. Now, how to find the displacement of yours? How to find the displacement of yours? Okay? Beta, distance is not displacement. Pay attention. Distance is not displacement. Right? Let us calculate. So you are a student. You started point A. Right? You covered the distance of entire your school and reached to the point A. Here the distance will be some x meter, right? I don't know the distance, but what will be the displacement in that case? Why you reach to the classroom again? The displacement in that case will be 0. The displacement in that case will be 0. What if you are a student A and you reach to the point B? You reach to the point B, but in this circular path, okay? This AB will be the distance in this case, okay? But will that be displacement? Remember what we studied in the start? Beta, displacement is the shortest distance between the point A and B. Displacement is the shortest distance between the point A and B, and hence we are going to calculate it. We are going to calculate it with the help of what data given here. Okay? So distance traveled is not equals to the curve of ABC. However, the displacement will be the straight line. Right? Now see, you have this circle. Okay? Whenever your motion is in circle, beta, and you are aware about the radius, so this is point O, this becomes C, the point C where you reached, okay? The point A from where you started, the B is the path you were traveling, right? Can you see a triangle being formed? Yes, triangle being formed, right? This is the hypotenuse of the triangle, base into height. So you are aware about that. Hypotenuse square equals to base square plus height square. This is how we will find the distance or the displacement. Okay? The second thing, beta, now if a person starts from the point A and again move to the point A, the displacement here will become 0, but the distance will not, because the person has covered the distance. And how you will find the distance? Obviously by the circumference of a circle. And what is that? That is 2 pi r. You know the value of pi, right? 22 upon 7. But now take certain cases. Let us take certain cases. Okay, this is a circle, this is a point A. A student starts from point A and reaches to the point B and reaches to the point B. So basically half a circle of it is covered, and hence the displacement will be half of the circumference. So what is the circumference? 2 pi r upon half. 2 se 2 cancel, it will be pi r. Okay, what if the student starts from the point A and reach to the point C? Beta, now the displacement, right? Now what is the displacement, beta? So it will be even half than this pi r, because it for half it is pi r we calculated. It will be pi r upon 2. Okay? This is how you can find the value of distance and displacement when you are in a circular motion. Right? But the uniform motion is not only in the circular way, rather it can be like this, right? In this case, an athlete is moving from the point, like he started from here, moved here, then changed in direction, then move here, right? It does not mean that the velocity cannot be constant. It can be, but the direction will be changed. Here it is hexagon, here it is round. Right? See, rectangle, 4 direction changes per round. However, in hexagon, 6 directions are changing per round. As the number of sides increases, the athlete turn more and more until he approach to the place. Here, what is changing? Direction is changing. So, whenever an object is moving in a way, in a circular path, constantly changing its direction, beta, the motion is called uniform circular motion. Like the earth is, right? The earth is revolving around the sun. But why? Why it is not changing? Why it is not changing its direction? Because of the gravitational forces, because of that fixed path. Let us understand that with the help of example. We take a circle. We will take a circle. As a tape, let us take a big tape. Okay? In that, put a coin. Okay? And try to like rotate it for a time. After that, take out that tape. Don't you feel that the coin will change its direction? Yes, because of the Newton's law of motion. See, until force was applied to it to move in a circle direction, it was moving. But when the force will not apply on it, it will start moving in a different direction. Okay? So place a tape ring flat on the smooth surface. Try it today only. Throw a marble inside it. Rotate it in the inner body. Predict it. What will happen when you will repeat it for several times now, and then remove the tape for a period of time. It will move in the same direction. But after that, beta, it will start moving straight. Okay, start moving straight. The marble moves off in straight line. It continues in the direction it was moving. See, moving, and then continues in the direction it was moving. Okay? And that is known as tangent. That is known as what, beta? Tangent. There are certain things we do daily, but we do not figure out in physics. So the uniform circular motion is accelerating. What is that? So there are certain common mistakes we do in our daily life. Okay, not understanding certain basics. So even though the speed never changes, beta, the chain of reasoning. Acceleration is non-zero if the velocity changes, right? Velocity changes if its magnitude or its direction changes. See, velocity basically depends upon two factors. One is magnitude, that is change in distance, plus that is change in direction. Okay? In a uniform circular motion, we just saw the direction is changing continuously. The direction is changing continuously. And hence the acceleration can be zero because the direction affected its number, its magnitude. Okay? The common mistake in everyday life, we say a vehicle is accelerating when the magnitude of its velocity changes. Beta, what happened na? Consider an example. You are riding a bicycle in this twisted curve. Okay? In this twist and turn wala curve. Now, when you are moving in a straight direction road, what will happen, beta? With constant magnitude, right? With constant magnitude shown in your speedometer, you will feel that by I am moving at the same speed in the same direction and same interval of time. Now, what will happen when you will get this twist and turn, right? Right? Your speedometer will actually change. Why? Because beta, as there was a slope, right, which is changing the direction for which you have to increase the acceleration, does not means that, right, does not means that your velocity is changing. Your velocity is changing because the direction was changing, the magnitude was not. The direction was changing, but the magnitude was not. And we often fail to recognize there can be acceleration where there is only change in direction. Okay, I hope this is clear to all the students out now. So here we have a lot of questions in the end which you have to do, and at the end, beta, what pointers we need to keep in mind? The distance and direction of an object with reference point at any instant describes its position. So from where we started the chapter, right? From where we started the chapter were 2 points, beta, that was distance, right, which is a scalar quantity, and that is displacement. Actually, these 2 pointers brief us about the position of an object in motion. Position of an object in motion, right? Clear? Very good. Displacement is the net change in position between two given distance of time. Okay. Then average velocity, displacement upon time. If the position of the object changes with a reference point change with time, this is known as motion. We learned about average speed, average acceleration, and kinematic equations that will help you to solve number of MCQs that are going to come in your exam. Okay? So I hope this was helpful session for all my students. Don't fall into the traps. Pointers are given here. And if in case you want this slide, this solved PPT, there is only and only one single place you can reach out. That is the AIO page we have. Okay. So the AIO page we have, that is Vedantu. Beta, see, the link is given in the description, right? The link is given here in the description. When you will just hit the link, you will get access to the courses, which is just at 0 rupees, which is just at what? 0 rupees. You can, according to your class, go and click, find the schedule, see the calendar view, and if you'll find any lecture, the lecture will be also associated with class slides along with the quiz available for that session. I hope you enjoyed the session, and if in case there is any doubts, please write it in the comment section right now, and we will be bringing more and more sessions like this for you. This was the very first chapter we have completed from your new class 9, the science book. Bye-bye. Up till next time. Meet you soon. Take care.